Okay. Hello, everyone. I hope you can hear me well and can also see my screen. If not, just let me know on chat. Okay. So you can also download this presentation from the FTP site. It is available there. So today we'll be talking about um, uh, the next part of service assurance, which is adding auto scaling and alerting to VNFs. So so we'll start with the current architecture, how the auto scaling happens in service assurance today. So if I can revisit what we discussed in the last session on monitoring, we have these three modules in service assurance. The MON module, which primarily does the monitoring, the POL module, which does the policy control part, and Prometheus, which provides the time series DB. And then we have the Grafana for the dashboarding, and we have an optional ELK as well. So we'll be talking mainly about the auto scaling and the alarm creation in the service assurance framework. The auto scaling means that whenever there is a threshold breach of any of the matrices, then the VNF scales with a certain granularity. You can provide the information about when to auto scale, on what condition to auto scale in the VNF descriptor. And there is another feature which is called the alarms, which is about so it's about if on a certain condition I have to also alert an external entity through a webhook, then an alarm will be triggered. So I can separately configure an alarm in the VNF descriptor as well. So if I can revisit the MON architecture that we saw in the monitoring session, there was so this is that three modules that we had in the MON: the MON server, the MON evaluator, and the MON collector. So the MON evaluator portion of the MON module gets the policies from the VNF descriptor, which is stored in the common DB, and it then decides whether an auto scaling or an alarm is required. So the evaluation part of the policy to decide whether an alert has to be generated or not, this is decided by the MON module. And then there is a POL module as well. It talks about it caters to the policy part of this. So whenever an alarm or an event has to be or auto scaling event has to be generated, that is actually generated by the POL module. It interacts with the MON evaluator to decide when the event has to be triggered and what has to be triggered. Is it an auto scaling, or it is a alerting or alarm that has to be generated? So the actual invocation of the event and calling the respective module for doing the work happens to the POL module. So if I can summarize all of them together, so so the MON evaluator, this is the complete architecture. get the matrix information from the common database, and it then get the current matrix values from the time series database, and then it decides whether there is a alert or alarm that has to be generated. The evaluation of the threshold happens in the MON module, and then the poll is called so that it can either go to the lifecycle manager for an auto scaling, or it can call the webhook for calling an external entity to alert it or send the alarm to that entity. So this is in totality how the MON and the poll works together for the auto scaling and alarms. So what we'll see now is the scaling part first, where the auto scaling is happening. So for that, you have to write a scaling group descriptor in the VNFD. So we'll be using the same slice, the slice one that we created in the first session today. And the scaling policy is already there in that VNF descriptor. We'll use that. So it has few interesting things, like it provides you the threshold on which the scaling should happen. It tells you how many instances maximum I can scale out, which video I will be scaled out, and what is the cooldown time before like the next alert can be generated. So that if there are multiple alerts are generated, then that can be stopped because of the same reason. The second part is the alarm description. The alarm description is the other way of alerting an external entity. What does this mean? That means the auto scaling scales the VNFs, whereas the alarms will let an external entity know through an webhook, so that if there is an alarm manager, it can be informed that it can take the alarm processing further from there. So for that, you have to write the webhook and also tell the when this has to happen. Okay, so what we can do now is we can go to our hands-on session and do the auto scaling and alerting ourselves, and then we can come back to the next part, which is the new proposal. So for that, maybe I can go to the hands-on section, and there we'll be using the same slide that we have created in the previous session. So if I can go to that. So you should already have this slice in your MON orchestrator, and you have the network slice already instantiated. So this is your network slice, and then you have the network service. So to scale, it needs a scaling policy. So before doing anything, let's see whether we already have the scaling policy or not. So you have to check in your VNF descriptor, the AGW or the access gateway descriptor, whether you have the scaling policy already created or not. So for that, what you have to do is you have to check the scaling descriptor. So you have a scaling descriptor here, similar to what we have just discussed. That is, you should have a threshold. You should have the parameter on which this threshold has to be applied, and how much it has to scale. Similarly, you will also have an alarm that alerts an external entity and tells like which webhook has to be called. So for that, you have to go to the webhook site. So I have also provided you the webhook details here. Like you have to go to webhook.site to see the webhook. Okay, so now if I go to the network service, so what we have to do next is so you have to find the VDU or the virtual machine which can be stressed. So we'll stress the CPU, and we'll use this command to stress. So what we'll do eventually is find out which VM to log in. So if you go to your OpenStack instance by logging in with your username, you will see this IP address. You from your OSM command line terminal, just do an SSH magma and that particular IP address. So my IP address is 91. So I will go there and I will stress. So magma is the password as well. So magma is the login and the magma is the password. Now, before I stress it, let's see where the Grafana. So if you go to here, you can see your if you have already successfully created this. You should already see the different matrices being monitored, and now we'll see whether I'm able to stress it so that the thresholds are reached. So before I do so, any questions anyone has, you can speak out now or put it in the chat. Okay, I believe there is no question. So what I will do now is I will go to this virtual machine. So how did I go to this virtual machine? I had logged in to the AGW VNF through SSH magma at the IP address that you have. You have to check in your OpenStack user the IP address of that, and then you have to play this command to stress the CPU. So let me go and stress it. So it has started stressing it. So you have to keep this IP address handy so that you can also kill this process later. So what I will do now is, let's see whether it has started stressing or not. So the CPU has increased to 99%. I have used the top command, but it will take some time to actually reflect in the Grafana. It's still showing around 3%, but it will take around 5 to 10 minutes to scale. To first increase the matrix, the threshold will be invoked after that, and it will start scaling. So till that happens, do you have any question for me? Okay. If there is then no question, then let me go to the next part, which is Fine. So it will take around 5 to 10 minutes to scale. In the meantime, let's go through the rest of the slide to and cover the new architectures. So I think the question is, can you reduce the time from 5 to 10 minutes? What time frame can be set for scaling? Okay, so there are two parts to this. One is whenever you are stressing a VNF or a video inside a VNF, then that matrix, the increase in the value of that matrix has to first come in CPU. Only then the scaling will trigger. And the second part is that between two successive increase, it will have a cool-off period that we have seen there, right? So the delay now you are seeing because of the matrix collection delay, because it is still not reflecting here in the Grafana dashboard. Once this increase start happening here, then it will happen. Okay, fine. So I'll take the questions when start scaling. For now, let me go back and talk about the future proposal. The future of service assurance is about the closed loop automation. And the idea here is that with the closed loop automation, I should have an autonomous network. So as the networks are becoming more complex now, so orchestration is becoming very, very important. So that we can bring automation in the network, and the human workforce who are doing all the complex things today cannot do it anymore because of the increase in complexity, increase of the data, and so on. So automation has to happen through the orchestrator. And so auto scaling alarms are the first step towards this closed loop automation. So closed loop automation will have 3 different steps. The first one is to observe. So we are using the infrastructure matrices today and different VNF matrices. And the idea here is that we should be able to add more telemetry interface. For example, the SNMP exporter that I discussed about last time is one step towards that. And then we'll add more telemetry adapters like gRPC adapter and so on, so that we have the advanced telemetry to observe the network in a more granular way. The second part is decide. So decide is what you are seeing as the policy for auto scaling today. That means I have a threshold to, and when the threshold breaches, the auto scaling starts happening. But we can improve this by having a correlated auto scaling. That means just not one matrix, we can have multiple matrices to decide together, which are evaluated together to decide when the scaling will happen. We can also apply machine learning in the decide phase to have a more complex decisions to be made. And finally, the act part, where we have 2 actions that we see today. One is around the auto scaling, and the other is alarms. There can be other things, for example, the placement module that is coming in, so we can have a intelligent placement of the VNFs. So this closed loop automation is our future vision. Now, for that, the one step that we are doing right now is having a more decentralized auto scaling and alarm. So In the earlier architecture or the present architecture, you have seen that um, the evaluation happens in the MON evaluator, and then the poll is called. Now this is decentralized so that every entity, let it be the VNF and the alarm evaluation through Prometheus, let it be the VNF's external alarms like the SNMP traps or the Vim, can directly call the poll, and poll can then decide whether it's LCM and webhook. So this will make it more scalable, decentralized, and there is no central entity which decides on the threshold and then the policy to alert, when to alert and how to alert. So every entity has now its own way of alerting, and then the alert comes to poll, and then poll can take it further. So it also gives you much more flexibility in poll in the future. We can also have things like correlation of different alarms and sending one alarm out rather than sending multiple alarms. So this is the like the basis of going for a more complex auto scaling and alerting systems. A few other things that we have in roadmap is automatically monitor the auto scale video. So we are only monitoring the initial videos that are there in the VNF, but if it is auto scaled, we're not monitoring that. That will be picked up. Setting thresholds on correlated matrices. That means we can have a more complex threshold rule, which will be based on more than one matrix. And so move away from the threshold to an ML-based anomaly detection approach. So these are few things that are there in the roadmap. If you have any questions, you can put me on the chat. In the meantime, let me see whether it has started scaling or not. So we had stressed it earlier. Now you can see that so the matrix value has increased. So it was somewhere around 2% to now 100% because we have stressed it. And then what we can also see whether the scaling has actually happened. So if you go to your OpenStack instance, so earlier there was one video. Now if I refresh, it's taking some time, but if you are also doing along with me, you would have scaled out for you by now. So let's see. Okay. So you see there is another instance video 2, which has started scaling out. And this is because of the stress that we had put in the initial video. The threshold root has hit and it has scaled up. At the same time, if you go to the webhook, so you will see your webhook page something like this. And if you go to the last page, so it's like 4:06 p.m. for me now, and I have a new webhook also invoked. So because we had put two different rules, one for auto scaling, so we have seen the auto scaling getting triggered, and a new video has appeared in the OpenStack. At the same time, the webhook is also invoked, and the webhook side we can see this webhook is getting invoked. So this is how the scaling and the alerting happens. Now you can also scale down, so you can bring it back to normalcy. So if I de-stress this, that means if I find that oops, did we do? Let's come back. So if I can kill this process, which was running in background. So now if you see your CPU percent has reduced to less than 1%. So now after again 5 minutes, you will see that the increase in the CPU matrix will start falling, and it will be somewhere around 1%, and then the scaling will start. At the same time, the webhook that was being continuously invoked will now stop invoking the webhook. So it will take 5 minutes or so. We can wait for 5 minutes if we have time. I don't know how much how I'm doing on the time, but if you have any questions, we can take it now. Let me see if there is a question. Okay, so what is the new IP address to of the new video? So this is the IP address of the new video. So it has an external IP address and has an internal IP address. You have to go to your OpenStack with login with your username, and you can see the new video scaled out and with its own IP address. But now today it is not monitored. In a future release, maybe we'll also start monitoring this part. So okay, any more question? My instance name is Magma Slice 1 like Hackfest NSD. Should not have my tenant ID. So what happens today is when so this is another problem, because today we don't have a multi-tenancy in Grafana. So this is also something we'll be looking into. I talked about this in my previous session. So all these charts are, all these dashboards are created here. So the only way of separating out your dashboards is when you create the network slice, you should give a different name to your network slice. For example, say if I have to, if my instance ID is 38, I should give an 38 as a number here. It will not come automatically. You have to give it in the name of the network slice while you are creating that. So this is how it will come. Okay, any more question? Okay. Subhankar is already answering the question. Fine. So we can wait for this to scale down, or if we are running out of time, then we can start the next session.
May I have the question?
Yeah, please go ahead.
Wojciech Mirantis. Hi. Okay. Do you plan to scale also the internal VLDs apart from VDUs? Because sometimes you get multi-VDU VNFs, and let's say for a pair of control plane and data plane VDUs, I would like to have a dedicated interconnect network segment. So if I scale the entire pair, like control plane and data plane VDU. For the next scaled out pair, I would like to have the dedicated internal VLD. Do you plan it or not?
Yes, I mean, that is a good suggestion, but we don't have this, at least in our current roadmap right now. So if you want to get this feature considered, maybe you can propose it in the tech session, and we can pick it up.
That's also tricky, because if you create a new VLD and you say the scaled one and this dedicated one, is actually not necessarily dedicated, because it may be using the same tunnel Open vSwitch inside the OpenStack setup. So what I would do today, which is supported, is to use SRIOV virtual functions, so that each gets a dedicated SRIOV virtual function, each scaled instance. And that way you're really getting some segmentation. Otherwise, you may be using the same VXLAN tunnel, so no additional performance for you. Anyway, if you have a specific use case, it can be proposed and evaluated, of course.
Yes, basically my use case is that, okay, the control and data plane VDUs actually use the same specific addressing on the interconnect link, right? So from the OpenStack perspective, if you say OpenStack to create this small segment just for interconnecting two IPs of VDUs, it will create separate networks and subnets, and they'll be separate UIDs in OpenStack.
Okay. Okay, so it's not a performance issue, but an addressing issue. You need additional segmentation, right?
Okay. Anyway, okay, I will switch this conversation to the channel maybe. So just wanted to possible right now, because in the model I could see that only the VDUs can be scaled rather than VLDs. Okay, thank you.
Sure.
Okay. In the meantime, you can see that the extra load in CPU has started falling, because we have stopped those stress, and now the scaling should start triggering. So let's see whether, so this extra VDU should disappear in some time because of this scaling. It has still not started, but it will start in a minute. But if you're already doing along with me, yeah, so the extra video has been removed because the scaling has started happening, and that happened because of the lower threshold that we have put. So it has gone beyond the threshold, so it is now in the normal region, and so the scaling has started happening. So what we have seen as a summary is we can add the policies in the VNF descriptor, which will have which metrics I want to use for scaling, what threshold I want to put, and what will be the threshold value. And then I can also provide whether it is an auto scaling or it is alerting or it's both. So what we have seen, both auto scaling and alerting happening together. So in the auto scaling part, the VMs scaled out, and in the alerting part, an external webhook was invoked. And scaling is just reverse of that. That means the normalcy has achieved. And the extra video that was scaled out, or the webhook that was being invoked, so that is stopped. So the extra video is deleted. The webhook invocation is stopped, So that I'm indicating that I'm now in a normal condition, and then a network need not go to a scaled version. So that is pretty much about this presentation. If you have any more question, I'm available on Slack to answer you, or you can also connect us with in the text session and propose anything new that you have in mind. Okay. You see if there is any more question.
Hi.
Hi. Virtually. Yeah. Go ahead.
Yeah. Small question. Can we use together auto scaling and manual scaling or not?
Yes. So manual scaling can be done anytime that you want, but auto scaling will be based on a policy. So if there is a auto scaling already there, so the MON will keep on evaluating the auto scaling parameter and it will auto scale. So if you do a manual scaling and at the same time a auto scaling threshold is triggered, so depending on which one goes first, that will be triggered. So manual scaling has no connection with auto scaling. Auto scaling happens through an automated rules, whereas manual scaling you can do anytime by yourself. Someone is asking me about the password. The password is same as the username, Magma. Okay, so password is Magma. So you can auto skip. Okay, any other question? Okay,
Sorry, one more question
Okay,
about manual scaling. Yeah. If we have, for example, 5 instances by auto scaling, can I use scale in for this instance or not?
Scale in using manual
Manual, yes.
Yeah.
There is an API call available for scaling out and another API call available for scaling manually. Same rules regarding minimum number of instances and maximum number of instances apply.
Okay, so maybe we can end this session and go for the next one. And if you have any more questions, you can ask me on Slack. So I'll take one last question that I see in the chat. It talks about in a virtual EPC, KPIs such as attachment success rate, authentication failure, etc., are monitored. Is the MON module intend to collect these metrics? Will OSM collect closed loop automation consider specific network metric? Yes, so that is the idea, that we should be able to collect the metrics from the VNF specific metric, like the one that you have mentioned here about attachment. Now, the architecture decision that we are considering right now is, should we directly take it from the VNF, or every VNF has its own NMS? For example, here also you see there is an orchestrator attached to the AGW. Now the orchestrator already collects a lot of KPIs, so it is always easier that I use its northbound interface to collect it and put it centrally in the MON. So we are deciding about that what is the best way of doing it. Should we get it from the EMS or the NMS of that VNF, or we should directly get into that VNF and taking it. So we have, so in summary, we have this in our roadmap, but this architecture decision has to be taken, how we collect this VNF specific KPIs, and then maybe we can have it. So then we'll have much more interesting threshold rules that we can set up.